Okay, there we go. Does everybody see that okay?
Yep.
Yes.
Great. Okay. So this is kind of a new presentation as compared to many that you might have even seen on YouTube or something. And I gave it last week in the UK, and it was actually the 10th presentation to the UK since we all started Zooming due to COVID. So we'll see how you guys like it. So, of course, a lot of people go to my website and sometimes they make assumptions that are not correct. So we're talking about interpreting my website. Just a minute here. Okay, so there's the top 8 radios. So if this looks familiar, you've been to my website, and we're going to talk about what these columns mean and sometimes the mistakes that people make that are I'm trying to fix. So let's go back 51 years. What data was published 51 years ago, let's say in reviews, and typically it was limited. So we had sensitivity in microvolts. And I still use microvolts because we can look at data for a brand new transceiver today in microvolts or go back 50 years. So that's why I've kept it in microvolts for sideband sensitivity. And also there was something about selectivity 51 years ago, maybe shape factor and, maybe it was a Collins filter and whatever it was. And there was a term called cross modulation, which was an AM figure of merit. I haven't heard that term for decades, so it's probably fizzled away. But all this changed in 1975 due to articles in QST and Ham Radio Magazine. So what did we get 50 years ago? Well, we got a term noise floor in dBm as opposed to microvolts. And a noise floor is a 3 dB signal plus noise to noise ratio measurement. And also a two-tone dynamic range test, also done with a CW filter. 500 hertz is the standard. And so we were looking at intermodulation products as they would just meet the noise floor, equal the noise floor of the radio. But the trouble was the testing at that point, 1975, was only done with two signal generators 20 kilohertz apart. And if you're saying, is that going to approximate CQ worldwide or D expedition? No, because the QRM isn't 20 kilohertz away and 40 kilohertz away. It's close in. I mean, most CW D expeditions are, up one or up two. This measuring only at 20 kilohertz was obsolete already if you owned a Drake R4C, which, as I mentioned earlier in our chatting, that's what's got me testing because the reviews said it's great, and in a pileup, it wasn't. So I figured out, well, something's wrong with the test. And then not long after that, in 1978, possibly the TR7 was the first up conversion radio, meaning the first IF was above 10 meters or above 6 meters. And that had typically a roofing filter 15 kilohertz wide, which is twice as wide as the R4C that already had a problem. So what was the problem? It was the topology changed. So we had a wide first IF filter and lots of gain. So then the crystal filter that would provide the second IF filtering was usually between 4 megahertz and 11 megahertz. So in this environment with really big signals, and you guys in the East Coast will have it worse than here in Colorado. And if you're in Europe, of course, it's even worse if you're on 40 meters. So the 20 kilohertz test data that appeared in the periodicals didn't show the problem. So I just squeezed those two test signal generators to 2 kilohertz apart instead of 20, which meant for most of these radios, the two test signals made it through the roofing filter. So the difference in the measured performance for dynamic range, when you did the 20 kilohertz, all you were testing was the front end, not the whole radio. So the typical numbers were 80 to 90 dB, while the typical 2 kilohertz data was 65 to 75. And that was a big deal, of course. Now today we have lots of radios that are 100, so it's critical. But back then it was just night and day difference on how the radio performed. So where are we today? Well, both QST and my publications list both 20 kilohertz and at least one 2 kilohertz in QST. Now, my website that you just saw a little portion of has 14 columns of actually 158 radios. A few of them are second samples because our direct sampling radios vary from sample to sample. So there's some duplicates there, fewer than 10 probably. So all the radios are only sorted, in other words, ranked by the 2 kilohertz third order dynamic range column. Unfortunately, most hams only look at that one column. And the other problem is all the other data for a given radio in that table is not ranked. It's whatever applies to that radio. Like, what is the noise floor? What is the sensitivity? What is the blocking? What's the LO phase noise like and all that? But that's what's missed by a lot of people. They don't realize. They say if the you pick, let's say you own radio number 5, and you say, well, every aspect of radio number 5 is better than number 6. That is crazy. Where all the ranking is by is close in dynamic range, which is a CW problem, probably really sideband no, because splatter and sideband dominates. So what happened that caused this presentation I worked on in the last few weeks? I was listening to a podcast, and I kind of like these podcasts. And the gentleman was comparing the new Yaesu FTX1, and there's a QRP model and a 100-watt model. Of course, they test the same for a receiver. And the dynamic range was 91. And then he compared it to an ICOM 705, a really nice little QRP radio. And that one dynamic range was 88, which is not enough difference you'd ever know that on the air. But the reviewer assumed because the 2 kilohertz ranking was what it was, the FTDX1 was a few spaces above the ICOM, that he thought that the Yaesu was more sensitive than the ICOM. But that was totally backwards. The FTDX1 SSB sensitivity was 0.9 microvolts, and the 705 was better at 0.67. Of course, you could turn preamps on and all that, but that was the problem. And so I said, I've got to try to see if I can't explain this better than I've been doing. That this is a ranking by one column only, and everything else, if you want to compare 2 or 3 or 4 radios, you got to look up the numbers in the table. So I'm certain you're not going to be having to manually compare 158 radios, but maybe you're going to compare 3 or 4, and this isn't a big deal. So you got to look at each one. What I don't want you to do is the following. Don't worry about the noise floor or the sensitivity, because almost all of us, certainly in an urban environment, the urban noise, line noise, birdie noise, wideband noise, every kind of noise we've got that we didn't have 50 years ago, believe me, is worse than the sensitivity, except maybe on 10 meters, who knows. But don't choose a radio by one number. See, that's what upsets some. The OEMs will say, well, look, the Yaesu's on top with the first 3, but you need to look at the whole radio. What works best for you? You may have a Yaesu, you might have an ICOM, you might have a Flex, whatever. But I never intended the table to say that who is ever on top is the only radio you could consider, because that's silliness. So what is important besides the noise floor that's probably adequate for everybody, or the sensitivity that virtually any radio is adequate? How does this radio work for you? What's the user interface? Does it have knobs? Does it have buttons? Or does it have an LCD? Or does it run with your computer? What's the display like? I just like the displays built in the ICOMs I happen to own and the 2 Yaesus that I'll talk about later. But I happen to prefer a standalone radio, take it out of the box and plug it in. But others want computer controlled radio, or maybe they want a 35-inch screen. So it just depends on what you want. And the ergonomics, is it easy to use or is it clumsy? And believe me, the ergonomics are all over the map. I would say the biggest difference across brands right now are the ergonomics, and what works for you. You're going to have to decide that on your own. And also the menus. I mean, you were just discussing menus and what was saved in a FTDX 101D. Well, do you have to go into menus in the middle of the contest to make some simple change? Hopefully not. Hopefully that's easily done with whatever the front panel is. So if you can, join a local ham club, become friends with the members. And if you're considering a new radio, maybe someone in your club already owns it and it would be more than happy to show off his radio to you. And you can see, does this radio work for me? And of course, if there's a ham store near you, make use of it. Luckily in Denver, we've got a ham store. But of course, there's not everybody has that, is that lucky. So one thing that's great today, the basic performance of all the main OEMs, and I'll say there's 6, are more than adequate. You can contest and DX with dozens of rigs today and not worry that your radio is the limit. It used to be like 20 years ago, everybody wanted a 100 dB radio, and now that's common. So there's choices by brand, of course, and cost and size. I'm probably not going to take a 35-pound radio to a soda location or even a D expedition. I doubt that you take a 35 or 50-pound radio, take 5 of them or something to a D expedition. So size and weight, of course, are important depending on what you're doing. So I'll explain what I tend to do. I mean, I've been testing these radios in the lab now, as I said, for 50 years, but really for the last 20 approximately, I've been using these in contests, mostly CW, but some sideband, because the CW contests are the acid test. But I ran multiple contests on CW the fourth quarter of 2022 with $1,000 Yaesu and a $1,500 Yaesu. And that's all I used for 3 months. My third operating position still had my ICOM 7610, but I didn't use it. I said, I'm going to really get to know these 2 Yaesu radios. So here was the setup for the FTD DX10. Instead of, you can see it there under the monitor. Now, normally there would have been an ICOM there, but for the 3 months, that FTDX10 was what I used. And then at operating position 2, there's an FT710 under the monitor on the left. It looks a little bit smaller than the other one. And so that was my contesting, rag chewing, whatever. Now, I didn't do any FT8, but so that's how I was lucky to spend that much time with these 2 radios, which I think you'll find is quite popular. Now, this is a portion of my website, but I want to make this clear. This is the top 26 out of 158 radios, but it's not the first 26 because there's duplicates. For instance, there's a K3 and a K3S. And then the direct sampling radios, there's often a second sample because the dynamic range due to the ADC chip are different. Every chip is different for an ADC chip. Not by an enormous amount, but several dB. And for that matter, this FTX1, I just tested a second sample last week, and it was 6 dB better than the first sample. And that's not unusual. I think the scatter we see on second samples on my website is between 2 dB and 9. So 4, 5, 6 is kind of typical. Now, you're probably never going to notice that on the air since we're talking about radios around 100 dB. But look at that. In the middle of this list of 26 radios are 100 dB radios. Just astounding. You couldn't buy that 20 years ago. And the prices are all over the map from, $1,000 and 12,000 and up. But the lucky thing is, since I have this place out in the country, that I've contested with 20 of this 26 that I got to use myself. Now, I haven't run the 101D, but I ran the 10 and the 710, for instance. So how do you select a new radio? Well, Why not pick one of the top 26? You can't go wrong there. That's a good start. And if you're married with one brand, that's what you've had forever, fine. Pick the price that fits your budget. Today, the price range for a new rig is $1,000, maybe even 900 to, well, actually, this Flex that has the 500 watt amp built in is $9,600. So that's quite a range. And again, the size of the rig depends on where you're going to be operating. So let's look at some of these numbers and see what they mean. So from left to right, we got noise floor is rarely an issue, like I mentioned, because of urban noise, but I'm out in the country. So I purposely picked a quiet location to move out there. Likely, band noise on 15 meters at a quiet location is higher than receiver noise. On 10 meters, it may be about equal. But depending on what your antenna is, if you're at a soda site or a parks on the air, maybe you've just got a halfway end fed or something that's up in the air 15 feet on one end. And so in that case, the sensitivity or the noise floor might be an issue because you've got a wimpy antenna because what are you going to do in a setup like that? But if you can, at your home station, improve your antenna before buying a new radio with better lab numbers, if you can. I mean, if you got an HOA and you've done all you can do, that's what it is. But there's nothing more important than your antenna. And I feel that directivity rejection is more important than gain. I mean, gain's good, let's say 6 dB, but your directivity of a Yagi might be 20 dB off the side and part of the back. So that really reduces QRM. One of the next columns is the AGC threshold. Certainly on the lower bands, band noise is above AGC threshold. But consider adjusting your AGC threshold. It's however it's set up, but if you're operating, whether you're trying to work a de-expedition and you're trying and trying, you've been on the air for hours, or it's a contest or whatever, if you can adjust your AGC threshold to be somewhat above band noise, that's going to reduce the fatigue because every time you're tuning between stations, let's say you're searching pounds like I am on CW, I don't want when I'm in between stations to have noise just as loud as every station I'm tuning in because of the way the AGC works. I even had a case where I was on 160 and in general I would use 12 dB attenuation on 160. At one time I used 20 with a 7300 and 18 with a Kenwood, and that was pushing it, but I loved it. Noise was almost not a problem, but I did have to turn the volume up every once in a while. So consider using your attenuator, your RF gain, or some radios have an AGC threshold adjustment like the Flex and the Apache. So play with it. See what you think. Blocking. Superhet radios will block eventually from an out of passband signal. It could be out of band. And the direct sampling radios, instead of generally blocking, they run out of the ADC dynamic range. For most of us, most of the time, blocking or ADC overload isn't an issue. I think for the most part, it's if you've got another ham line of sight. He could be 10 blocks away, or if he's in the case of like in Boulder, Colorado, one ham was up into the foothills above Boulder by about 1,000 feet, but the Boulder hams were 5 miles away, and that blocking was an issue. So what number is kind of adequate for almost everybody most of the time is 125 dB. And that's about typical for a direct sampling, but like a K3S, that's 150. Sensitivity, that's the microvolt value that I talked about earlier, but instead of being a 3 dB signal plus noise to noise ratio for noise floor, sensitivity is a 10 dB signal plus noise to noise ratio. What's a typical value that's more than adequate? Well, if we can go clear back to a Drake and a Collins or a modern radio, Now, the Draker or Collins, of course, didn't have a preamp you could turn on and off. It had an RF stage, and it was on all the time. So about 0.15 microvolts was fine. For CW, this is CW. But then a modern radio with preamp 1 on would be about 0.15 microvolts. The same value applies to the legacy radios in current, which makes sense. I mean, you need enough sensitivity, but not more. Local oscillator noise probably isn't thought about much. In 2012, the league started publishing reciprocal mixing dynamic range, which dealt with local oscillator noise. Now, your legacy radios, like Drake Collins, for example, they didn't have noise problems. They had a PTO, permeability, tuned oscillator, a VFO, and band crystals. All of those are low noise. But guess what? When the synthesized radios came along and everybody liked them, they didn't drift, they had digital readout, but they had terrible noise. So that's what we were stuck with for like 20 years. Matter of fact, the OEMs really getting that fixed was only in the last 5 years, approximately. And certainly in the last 10 years, there hasn't been a really big problem with LO noise. If you want to go look at a QST review and it lists an RMDR, reciprocal mixing dynamic range number, you go to my website, it doesn't list that because my data goes back 50 years, but it has an LO noise column, and that's in a 1 hertz bandwidth. And of course, you don't measure it in 1 hertz bandwidth, but that was the standard, and it still is. So if you wanted to compare the two, just subtract 27 dB, change the sign from negative to positive, and that's your RMDR. So if it was minus 137 dB and 1 hertz, the RMD value would be 110. So you can compare it to QST if you want. Front end selectivity. Most rigs have either a half octave or a ham band only LC front end. A few have a tracking preselector, like the FTDX 101D or the MP or the ICOM 7610 or the 7760. On 40 meters, the minus 10 dB bandwidth. In other words, we're going to say how much are we down at whatever offset to be down 10 dB that would make an improvement if we're having some sort of an overload problem. Well, the FTDX 101D on 40 meters at minus 10 dB on that LC tracking filter is 250 kilohertz wide. The ICOM 7610, 500 kilohertz wide. So I get people saying all the time on these reflectors that if I side tune the tracking preselector on the 101D, it gets rid of QRM. Well, that doesn't make sense. We're talking about a 250 kilohertz wide filter. But what it is doing is inserting insertion loss, which is just like turning on an attenuator. And as I mentioned, it's kind of nice to have the AGC threshold set properly. So I think that's what's mostly happening. So I'd just be skeptical of a magic QRM reduction by side tuning a tracking preselector. The main improvement, particularly in Europe on 40 meters, would be knocking down the broadcast stations above 7.2 megahertz. If you can knock those down 10 dB you're on the East Coast or you're in Europe, that's a big deal. And for field day, you may need some additional filters too. So finally, we're back to dynamic range. So with more than 20 transceivers with a close-in 2 kilohertz dynamic range of over 90 dB, most hams don't have an overload issue. One thing though, if you have another ham very close by, in my case, the closest ham is 13 miles away, so no problem for me. But if you do have a roofing filter, you can have about a 20 dB improvement in exceptional cases. Line of sight, the guy's 60 over 9 or 70 over 9, that's your neighbor. Field day, you've got CW, digital, sideband, all in the same band if you've got a really big field day operation. Or a multi-contest, whether multi-2, multi-multi. The multi station's trying to work signals really close to the run station, and a roofing filter really helps. This is a little techy here, but let's just say, when does a radio overload? And I'm going to put this radio on 10 meters. This happens to be a 7760, could virtually be a 7610, but any radio that's basically a 100 dB radio. So in my case, in my rural QTH, when I'm pointed to JA, my band noise can be as low as minus 130 dBm. Now, if I'm pointed to the Caribbean, it's usually 8 or 10 dB worse. But let's just say we're going to be measuring and see, when does this radio going to overload or start to overload? So if the noise floor of the radio, in this case, is just a little bit less than the band noise, and so the calculations show that you would start theoretically to see distortion products showing up right about the noise floor with signals that are S9 plus 40 something. So that's pretty good. I mean, we're talking about signals from, like minus 130 clear up to S9 plus 40, 45. So that's darn good. That shows you how good these 100 dB radios are. Now, one thing that I think was a bit misunderstood was some of the people running direct sampling radios at WRTC in Europe the last time, and I think we've got our WRTC coming up next year. They were running 9 dB attenuation on a 7610, where otherwise the overload light was on. Well, I'd probably pick 15 dB. Band noise at night, and this is all out of your handbook if you want to know this. Band noise at night's about minus 100 on 40 meters on an omnidirectional antenna, which is what the data is. Well, the noise floor on most radios are minus 130 or better. You don't need 30 dB difference between band noise and your noise floor. That's just not optimizing your radio for potential overload. So I would, instead of saying, well, I'm using the least amount of attenuation possible to make the overload light go off at 9, I would probably pick 15 and been a happy camper. Because the problem was those stations above 7.2, broadcast AM stations, probably running a megawatt or 2 megawatts, who knows, or maybe the 49 meter band that's just below 40 meters. So one mistake is often made. Frank Donovan, who's W3LPL, he's got one of the top multi stations, and he tells me that at the end of a contest, he'll go look at all the radios, and people had them set up wrong. I mean, radios are sensitive enough for 10 meters and now 6 meters. Everybody's new radio covers 6 meters. So the trouble is they're sensitive enough for 10 or 6. They're too sensitive in most cases on 160, 80, and 40. So if you're using a preamp on the lower bands, don't. Use your attenuator, RF gain. I would say for most radios, most of the time on 40, 80, and 160, play around with a 12 dB attenuator at night. No, not necessarily 12 noon, but at night. So what's changed? Well, up conversion radios, that's all we had for 20 or 25 years, were replaced with what we call down conversion, or low IF radios. The Orion 1 came out, and that was the first one to make the change back to kind of the old days way. Then the K3. So the up conversion radios with a 15 kilohertz first IF, and then a whole lot of gain, and then a DSP became obsolete really quickly. So both the Orion 1 and the slight improvement in Orion 2 and the K3 and then the K3S have a low IF. And now that includes 3 Yaesu rigs and 2 Kenwood models. The typical 70 dB, 70, 2 kilohertz up conversion dynamic range couldn't compete with radios like K3S or the other down conversion radios like the K3S, 105 dB. The only exception that didn't get blown out of the water was the ICOM 7851 at about $13,000, which has been discontinued, and it had a little over a 1 kilohertz roofing filter at 64 megahertz. Expensive radio, but it had 105 dB dynamic range, just like the K3S. Note, if you're paying any attention to the IC 7760, which has a remote head, which, by the way, you can just take the remote head loose and use it at a hotel, or you can buy a separate remote head, kind of like a K30 or something like that. Um, so that is a direct sampling radio. It's not a superhead like the 7851. It does not have a roofing filter. So what about direct sampling rigs? Currently, those on the market that I've tested, the dynamic range is between 97 and 107. Probably you never noticed the difference on the air. And that's with the linearization turned on, which makes the lab numbers more consistent. Some people feel that on the air it doesn't matter, but it's hard to tell. But even the ICOM 705, which is that QRP rig that covers 160 to 70 centimeters, it doesn't have that linearization dither option, but still the dynamic range is 88. Who's going to complain about that? I'm saying that your 90 up is more than you probably are ever going to need most of the time in normal RF environments. Now, one thing with a direct sampling radio, it doesn't matter whether you're testing it at 20 kilohertz or 10 or 5 or 2, because it's just a different architecture. So you don't see that big difference like we did when we were looking at our TR7 or ICOM 756 Pro 3 or whatever. So what do you own now? I'm often asked, why don't I normally use the top Yaesu rigs on the website? Well, as you saw in the pictures, I did use the FTDX10 and the 710 for 3 months. For me, the user interface of my 7610 or even my 7300 fits me better. It's just how my brain works, I guess. So the user interface, the ergonomics, the band scope, the waterfall, all that stuff, that's subjective. What works for you? And that's all that matters. So I'm glad that I did get to run the two Yaesus for all that time, but I found the user interface less intuitive, but that's maybe just my brain. So what's different on transmit? We've only looked at receiver issues. So what's currently available to clean up our signals that cause QRM? The biggest difference is pre-distortion on sideband. Now this ARRL Clean Signal Initiative, hopefully by January, they'll start publishing some radios that actually pass this test. But the most obvious one, as far as night and day difference, is the pre-distortion, which is software. So now 3 of the top 6 OEMs offer some kind of pre-distortion. The Apache Anon has had this pre-distortion. They call it Pure Signal, written by Warren Pratt. And our Zero V, who lives in Lebanon, Colorado, about an hour from my house, he's had it for the Apache for more than 12 years. ICOM came out with digital pre-distortion over 1.5 years ago. And Flex now has pre-distortion. They're calling it Smart Signal, currently in beta. And it's not yet supporting an external amp. But we've got 3 now of the 6 major OEMs with pre-distortion, and we'd like the rest of them to come along. So this is going to be a screen capture from a station in Boulder, W0IVJ, Tom. And I was on the air with several other people, and so he captured some couple interesting screenshots off his receiver. So Class A is gone. It used to be if you had a Yaesu 5000D, you got Class A an option, or the Mark V. Unfortunately, the 101 MP does not offer Class A anymore. So that's not an option. ICOM has the digital pre-distortion. The K4, who knows? That's been promised for 5 years and hadn't shown up yet. So this signal in the waterfall in the middle is an Apache 200D with pure signal pre-distortion, adaptive pre-distortion, and the amplifier is in the correction loop. Look how straight up and down that is. There's just a hint of a little splatter every once in a while to the right, just barely there. And we can even see some sort of spurious from somebody switching power supply or phone charger or who knows what it is. it's pretty obvious. You can see that little signal to the high side of this Apache because the Apache isn't wide. But the station below, guess what? That was NC0B. That was me with the TS890S and an Alpha 89. Of course, that did not have pre-distortion. And look how wide it is. Now, the signal's a little stronger, but that not enough to make a big difference. So in general, with any radio today, particularly with a solid state amplifier, where the total bandwidth at about minus 50, which you can see on the waterfall, is about 3 times the bandwidth of the desired signal. So that's a pretty big deal difference. And you can see this if the signals are strong enough on the air. Of course, if they're S7 and the band noise is S4, you're never going to see all that. So here's the other one that he captured. In this case, I'm not the goat. So the signal there in the middle in the waterfall is me with a 7610 with a digital pre-distortion driving an ACOM 1000 that is not in the correction loop. So look how much just cleaning up the transceiver that's driving the amplifier with, in this case, a tube amp, because tube amps are much cleaner than LD-MOS amps. So I'm really happy with the way my signal looks. You can see a few dots off to the right edge of my signal, but not much. In this case, the signal below was a Flex 6600M. That was their flagship up until recently, driving a Power Genius. And they make a big deal about the Power Genius. Looks pretty much like my Kenwood and my Alpha. That was W5AP. One thing that was handy when this picture was snapped, the Flex just started to transmit again. So up at the top where the band scope is and not the waterfall, you can see the sideband splatter to the right and to the left is down about 30 or 35 dB. So it's visible with the band scope in addition to the waterfall. So Apache Anna Pure Signal by Warren Pratt, NR0V. While all pre-distortion solutions right now work barefoot, not all support a third-party amplifier in the correction loop. Pure Signal has always supported a third-party amplifier, and all you need is an internal or an external sampler, typically like minus 50 dB sampler. Pure Signal continually recalculates a mathematical solution to the distortion. Now the ICOM is different. You have to calibrate the ICOM into a dummy load, and it doesn't recalibrate one way or the other. It's just what it is. With the Flex, it will recalculate a solution if you change frequency by more than 10 kilohertz, or if you adjust the power level by even 1 watt, which seems a little silly. But anyway, so the 3 types that are out there, one is calculating all the time. One makes a calculation and sort of stores it in a table unless you change frequency. And the other one, it just is what it is, like with the ICOM. But they all work. You look at the ICOM one, how clean my signal was in comparison. And it doesn't, it just calibrate it once and it pretty much stays fine. So the ICOM digital pre-distortion arrived Thanksgiving Day 2023. Now, what's disappointing is the ICOM solution only works with the PW2 amp. So if you have a PW1 or an Alpha or an ACOM or whatever, it's not going to work with it. Now, just some, I guess, maybe interesting information, but the net result doesn't matter. The 7760 is a 200 watt rig. In barefoot, it's about 10 dB cleaner than the 100 watt 7610. But by the time you drive a PW2 with that in the correction loop, it doesn't matter because the PW2 is the limit. I think the 200 watt rigs are really popular in Japan because there's a 200 watt license. So the 7610, 200 watts, the FTDX 101MP, the TS990S, and the Apache Anna 8000, which is out of production. The Flex Radio pre-distortion It's still in beta here in August, well, September now. I had lunch with Steve Hicks and Warren Pratt, who wrote the Apache software, this past Saturday. And he thought it might not get out of beta till the first of the year, but maybe sooner. Who knows? So right now, if you've got uh, a Flex 8000, it works barefoot, but not with an external amp. Now, Smart Signal can calibrate with voice or with two-tone tests built in. Whether it recalibrates every 10 kilohertz, probably who cares? But the Smart Signal is only supported by the Flex 8000, not the 6000, and it will be supported by this Aurora 500-watt transceiver. Of course, it's not shipping it. So things to consider. You've got great choices today from all 6 OEMs. Try to operate a new rig if you can before you buy it. Few hams really have to worry about overload today. I mean, we're looking at more than 20 with a 90 or better dynamic range. Close in, so, CW pilot, whatever. So we need Elecraft, Kenwood, and Yaesu to offer pre-distortion to help clean up our bands. Luckily, if you have a tube amp and your exciter is cleaned up, you're in good shape. But just to reiterate, don't pick a new radio by my one number from my website. That's not the whole picture, which should be obvious, but it obviously has not been. And hopefully I can get this across to people looking at my website. If you have any questions, send me an email. Of course, your club has a copy of this PDF. It just frustrates me, though, when people make assumptions about the data on my website and it's not correct. So if you are going to compare a few number of radios, look at the data and all those other columns if you're looking at it from a number standpoint. You might well just decide, I like the way this radio works and I don't like the radio interfaces with me. So you pick the one that works for you. The bottom line, this is a hobby. You should enjoy using your radio. It should be fun. There's my email address, rob@nc0b.com. I'll stop sharing and tune it back to you guys.
Well, that was just a great presentation. I thank you very much. Anybody else have any questions? Go ahead.
Yeah, hi, Rob. Thanks for the presentation. It's very good to not just talk about the numbers, as you say, but to relate the changes that have happened in architectural aspects of radio over the decades and what's happened more recently. I do a couple of comments. So I think the point you make about how clean is the transmit, since you talked about that last, take that first, how clean the radios are. Again, a lot of people over this side of the pond are only just getting to grips with having linear amplifiers on the end of their radios because they live in residential places which aren't very sociable to have to run more power. And of course, our power limit used to be 400, whereas now there's a kilowatt. So a few people are getting into linear amplifiers here now, and quite often these solid state ones, and they don't really understand that there's a pairing issue potentially with the radio combination in terms of this, how clean the signal's going to be. I just worry about that in the sense that it really is only, and I welcome your view on this first of all, it really is down to the competition of other manufacturers able to say, well, we do this, so we're better than you, and it forces the others to do it, because most users actually care about what they hear. They don't care so much about how they're heard, like, right? So if their signal's dirty, it doesn't affect them usually. It affects everybody else. And whilst a lot of people would like to be good citizens, actually, when it comes down to it, most people look at the receive thing. Am I hearing stuff? Am I working stuff that I want to hear? If I hook decent antennas up to this decent radio, do I get what I expect to get? So I think there is still a problem there, and maybe you agree or disagree. There is a problem in the user aspect of this because the user doesn't really get affected by the transmit quality. And if they did, then it would be a whole lot easier to fix because it wouldn't be down to the manufacturers trying to outdo each other with pre-distortion promises. So that was the first thing. Second thing quickly was whether have you come across that Hiberling, really, 13 grand's worth of pounds over here anyway. I don't know what it is, probably a bit more than that in dollars. German ultra premium radio, they call it. I've no idea what architecture that is. I presume it's a direct sampling, but I could be wrong.
No, it's not. It's a super hit.
It's not. Okay. It's a super hit. All right. Okay. So how does that perform? Do you have any idea of, I mean, can something really be worth the extra in that, or are you paying for the badge name like a Rolls Royce or a BMW? That was my thoughts on that one. Um, I'll leave it there because other people want to ask things.
Okay, well, let me cover let's see, what was the first one? I'm sorry.
It's about the people caring about the transmit
Oh, yeah,
quality
right.
and
Well,
whether it's
you're
down to the manufacturers.
right. You're absolutely right. And people can even talking to someone who has a terrible signal from a splatter standpoint, but it doesn't necessarily sound that awful in passband, let alone the
Right.
fact that they don't hear their own splatter. So it is a terrible problem. It's going to have to be a learning experience with the RSGB, or the CQDL still exists, and QST and all that. That's why part of the reason this QST ARRL Clear Signal Initiative started. Terrible
Mm.
key clicks can be a problem. And sometimes you can go into a menu and make your key clicks worse.
Mm.
So, and then a transmit composite noise, which again bothers everybody else. And so, yes, it's going to take some articles in our periodicals, let alone people talking about it on the air. But right now, we've got 3 of the 6 that have pre-distortion. So hopefully, even if the guy doesn't understand why or care, if he can uh, get the other 3 OEMs to provide pre-distortion, this will be a big help. Hilberling, yes, I had the chance to own one, well, to use one. I didn't own it for about a year, and
Right.
it's changed architecture a bit. It was always a superhead. It's pure uh, analog, and it has 16 hole crystal filters. When I first used it, the narrowest CW bandwidth was 500 hertz, which for me as a contester, I'm S&P realized it on CW, 160, 10 meters for the most part, but sometimes CQ Worldwide on 20 meters or whatever. 500 hertz at -3, which is more like 600 hertz at -6, was totally inadequate for me.
Yeah,
So
it would be for me.
I talked to Hans, and he redesigned the filter board, sent out 2 filter boards. A local ham here, Ken, installed it for me because it was a rather complex deal to take the radio apart. That
Yeah.
had a pair of 250 hertz, again at -3, so it was more like 300 hertz at -6. I still didn't feel it was adequate for a CW contest or DXpedition. I mean, as things get busy at night, I'm usually down to 150 hertz.
Yeah.
There were some other funny things that happened that I caught. And so actually, after Hans and Jan were out at my lab early on, these other problems that I found, Jan flew out again, did updates to the radio. At some point, the crystal roofing filter they were using, the company that made it lost the recipe. And passive intermod in the crystal filter became the limit. Now, Hans did want his radio to be top of my list, and at one point for maybe 6 months or however long it was, a year, I don't know, he was at the top, but at a very big price. So the
Right.
the radio, I don't personally, I'm never buying $10,000+ radios again. I bought a 7800 when that came out, and I consider that the total waste of money. I only lost $500 when I sold it, so I'm happy with $3,000
Yeah.
radios. But I
Yeah.
mean, I've got 6 towers, 9 HF Yagis. I put my money in my towers and my antennas.
Yeah, that's very wise. The last one I was going to ask was about the Chinese radios because there's a big proliferation of those, and because they're so cheap, they're actually very popular amongst the Zygoos and the various other manufacturers, and I guess they're all SDRs. They're all put together. You can flash the things over with dodgy sort of systems that you find on the net and all this sort of stuff. It worries me a little bit that some of the people coming into the hobby are choosing this and thinking that's the end of it. That's the whole thing of amateur radio. And not really understanding whether there's issues with those beyond the price, because it's a cheap way to get a multi-band HF radio that you can carry around in a very small package. But I can't. I've never played with them, but I can't believe that they're up to the same standard as something that costs a bit more.
Well, they're not. Now, the G90 Zygu is on my website. That
Right.
Russian radio that's Lab 599 and whatever the other rest of the part number is, that's on my website. There's about 11 QRP rigs, and most of these things out of China are either 20 watts or less.
Mm.
There's also these $1 and $2 and $300 radios that the leak tests, and I don't bother with. I mean, I could spend my lifetime testing $100 radios, but I guess I'm a
Yeah.
snob. Anyway, it is a problem. And also, usually when you're trying to test these really inexpensive radios, I'm not talking about the G90, but they've got spurious trouble. I mean, there was a QMX that I tested that the league bought, and their numbers were kind of screwball. And they sent it out to me, and I tested it, and I got screwball numbers and spurious everywhere. I mean, everything except the noise floor were limited by spurs.
Right.
So this is something that the average user will never understand. New
Mhm.
guy, he just got his tech, he just got his general, he's on 10 meters or
Yeah.
40 meters
It
CW,
bothers me
whatever.
too. Yeah.
Yeah. So I don't want to say don't ever buy a $300 radio, but I would prefer you went to your Hamfest and found a 20-year-old radio for 300 bucks and have a lot better product.
Yeah, it's just very hard to advise these guys who are thinking that oh, well, you've been in it, 40 years or whatever. You've got more resources than me, so you bought a K4 and a 101 or whatever. I'm not in that position, so I bought a Z or whatever I bought, and it is very good value for what it is, but they won't see the spurious signals, I guess. So
Well,
yeah,
one thing,
thank you.
Steve, I think Eric was raising his hand. So just a second. The and I lost my train of thought. Oh, when Bob Allison was the tester at the ARRL, he always wrote a sidebar. And there were some radios that he said, don't ever hook this radio up to an amplifier because it's so terrible now. You're just going to be 10 or 15 dB stronger with a terrible radio.
Yeah, yeah.
So, Eric, did you raise your hand to ask something?
Yeah, I just wanted to ask when the first transistor radios came out, aren't transistors inherently there's something in the physics, I think I don't understand it enough to describe it, where they create some internal noise within the transistor. And is that where that local noise is coming from in local oscillators as opposed to the tube radios? And have they found a solution to make those lower noise internal to the oscillators or in the transistors someplace in the later radios, I guess?
Okay, well, there are two problems with the early radios. We'll take the Yaesu 101, like not the D, obviously, but the old ones from 30, 40 years ago. They had poor dynamic range. They had too much gain before they got to selectivity. Maybe you could say they were a bit noisy, and somewhere I know that uh, there were some mods for like a 1000 something that they added more preamp gain, but of course it ruined the dynamic range, but it made it quieter.
Hmm.
But the um, the problem now is not in-band noise, but the OEM's learning to make a synthesizer that works or a superhead. Now, a direct sampling radio just needs a clean clock oscillator. A radio with a synthesizer, and now look at like a FTDX 10. That's got a superhead front end, and then DSP at IF or ADC at IF. So what really fixed things, and like the Kenwood 990 was a start, and then the 890 really fixed it from their standpoint of LO noise. The oscillator is running at hundreds of megahertz and divided down. When you divide an oscillator down by a factor of 2, theoretically it's 6 dB cleaner. Now maybe it's only 5 because it's the real world. But if you're dividing down, a gigahertz signal to be the LO at 20 meters, you've picked up a lot of improved local oscillator noise. So it's really an issue of learning to do that. In the amateur world, I'm sure that some commercial world knew what they were doing, but it really took about 10 years to start getting it fixed. And really, from the Yaesu standpoint, in the last 5 years, they've just night and day better.
Mm-hmm. So it's a matter of sort of, can you say the DSP does some filtering of that noise?
No, not really.
Not really. Okay.
It's how you're producing your LO if it's a superhead.
Uh-huh.
Now, like with the FT710, that's a direct sampling, but all you need is a really clean oscillator, crystal oscillator. That's not hard.
Mm-hmm.
So we're lucky now. I would say anything that came out in the last 10 years, forget about LO noise as a problem.
Mm-hmm. Oh, okay. And also, Rob, is that pure signal hard to implement? Is that why some of the others haven't done it, or is it a price issue? Or
I think it's clever programming. The software that Warren Pratt writes is just stratosphere. And he's even got some noise reduction that has like a 40 megabyte noise table, and he's called it well, now that I'm forgetting the name, but anyway, it looks at his noise table and looks at his noise coming in the radio and says, what's the best solution to try to counteract that noise? So I don't understand why it's taken Flex years to finally come out with it. Obviously, ICOM knew that they wanted to do that. A 7610 was designed about 9 years ago and came to market about 7.5 years ago. And it was just sitting there waiting for a firmware update to do digital pre-distortion. So they had that in mind a long time ago. Now, why they waited that long, I don't know. Possibly because the PW2 wasn't out, but anything that got delayed, super delayed, like 5 years. Elecraft's promised it for 5 years. I don't think they've written any code. They've got a lot of things on their plate. The K40, the K4HD, transverters, whatever. So I think it really comes down to how good are your programmers thinking out of the box. Now, I think you're familiar with David Hirschberger. He wrote CESSB, controlled envelope signal sideband, which reduces overshoot after you've processed a signal. So that picks up a couple with 2.5 maybe dB in talk power. That was a software algorithm that he published, and then Flex and Elecraft and Apache implemented it. They had to write their own code. David wrote the concept in effect, and then those three OEMs had to make it work in their radio. And he may have had something to do with writing Flex's pre-distortion that's currently in beta. So I don't think it needs to be built into the radio so it'll do it. And the K4 supposedly is. I'm sure it is. They say it is. And the Flex was. So the radio has to be ready electrically, mechanically, but then you've got to have somebody that can write the code.
So Thetis running on a $300 radio, Hermes Light 2.
Yes.
Will do pure signal.
Yes.
Thetis is the same, it's tweaked for the Hermes, but it's the same software the Anon from Apache Labs people use with the Anon. So you can get it on a $275 radio.
Exactly right. And now like the Apache G2, it'll work on that, even though it's different from the computer standpoint. But so there's no excuse from a cost standpoint not to do it. You're right. Absolutely right, Steve.
Open, it's available, open source, and a bunch of us are running it on Hermes Light 2s through a $50 Chinese amplifier through an SPE expert amplifier, and we've got walls.
Yes, just like the picture I showed, right? So uh, I would hope that competition forces the issue, because if you just imagine if the other three OEMs can get with the program within a year or two, and then down the road, 5 years, people get new rigs probably every 5 or 10 years, some, and we won't be seeing these signals that are 3 times as wide as they should be.
Any other questions? Well, I think that sums it up. You did a great presentation. Steve, you got a question?
I just want to say thank you. I learned so much, uh, even your discussion of the comparative things, just understanding what's important. Before I had the 101, I had a 3000 with all their mu tuners. I live in the city of Philadelphia, and I'd switch them on and they would knock down the noise. I didn't understand why. Now I understand why. Thank you.
Eric, you had your hand up again.
Oh, yeah, no, I was listening to Steve and I forgot my question. So somebody go ahead.
Yeah, I was wondering how much, Rob, do you do with the Clear Signal Initiative? Are you giving input to them on what should be the next one after where they're at now?
Well, I'm the vice chair.
Okay.
And so, what do you mean by the next one?
Well, where once you get the first round up of the performance specs, what'll be the next thing that the Clear Signal Initiative will try and attack to make the band a little bit better?
Well, from a transmit standpoint, he's dealing with key clicks, sideband splatter, and transmit composite noise. Composite noise means phase noise plus amplitude noise, and something that wasn't well understood by the OEMs and even some really good engineers who know how to do things perfectly. In the real world, things aren't perfect. So actually, AM noise has been dominant most of the time in most rigs over the phase noise, once we got the phase noise reasonable. So there is a radio that passes CSI right now, but it flunked FCC on 6 meters. So we're waiting for that to get fixed. And then once that gets published, that'll be the first. Now, the thing that we're arguing about right now has nothing to do with transmit. It deals with testing receivers. And that's a place where I've been at loggerheads with the league since 2010. I prefer that we don't do something exotic external to the radio to make the numbers bigger. But the other argument is, well, in some cases, the bigger number is important, and it may be. So the next thing that has to get ironed out at the end of this month will be deciding on the testing of the receiver side, which really isn't part of CSI, except the reviews, of course, are more oriented towards the receivers with just key clicks and, well, those three things that are being a product review. So we're trying to get everything kind of ironed out. I don't know that there'll be anything added to CSI from what we're doing on transmit, but we were trying to stabilize the receiver testing so that it's more consistent from decade to decade.
As time goes on, most of these manufacturers will try and meet the CSI initiative, which should clean up the whole band. And if we had something similar to the receivers, then people could use that as a comparison. I.e., somebody was saying, yeah, maybe it's an IEEE standard of what a receiver should operate as.
Well, Ed Hare's into the IEEE stuff. I'm not. I'm just into what really affects us on the air and what I've been doing for 50 years. But anyway, neither here nor there. But if the first thing that every OEM should do, and no one so far has done the firmware update to, for instance, get rid of key clicks. A lot of the radios, if you can adjust it now, you can adjust about half of them. You can adjust the rise time, about half you can't. But if you go into a menu and say, "Oh, I'm going to pick 1 millisecond rise time," that shouldn't even be an option. 1 millisecond makes terrible key clicks. So I would say if you do own a radio that has a rise time listing in the menu, pick the slowest number, like 6 milliseconds or 8 milliseconds. There was one 10 tech that went to 10, but it really wasn't 10, but that's what the menu said. So key clicks should have been easy to fix. And everybody now, every radio's got software and it can be flashed. So the key clicks should go away like last month. and pure signal, well, we're halfway there. Composite noise is tougher. There's probably never going to be a firmware update that fixes composite transmit noise. That'll have to be a design issue. So the next radio that an OEM comes out with, hopefully they're pay attention to composite noise. And Yaesu is, for instance, their composite noise is quite good with current rigs.
What about, I always thought with key clicks, couldn't you somehow synchronize the oscillator such that you only have transmit on a zero crossing of the RF?
Oh, that would be in microseconds and not milliseconds. So that'd be way too, that wouldn't buy anything. We need the rise time. Well, there's two things, the rise time and the fall time. Plus the shape, and you can play with it. And even like Flex has said, you can play with the shape and you can move the key clicks around. So I know like Warren Pratt has written the code for the Apache to take care of the key clicks to pass this test. It was a decision like, okay, this is what we have to do to pass the test, and the test is really stringent. So you need to look at the wave shape and look at the rise time, and hopefully get rid of these really fast ones.
I thought. Sorry, Eric, do you want to go first?
Oh, go ahead, Jonathan. I'll go after you.
Okay, great. So I was really interested in the 2 points that Rob stressed about: one, AGC threshold settings correctly, and also secondly, at use of the attenuator. Now, on the use of the attenuator, again, that's counterintuitive for a lot of new people coming in to press a button that says, "I'm going to stop your signal and I want to hear more," right? It just doesn't compute for most people coming into this because they don't understand. They're appliance operators. They turn the knob, they press the button, and they expect to hear something. And now, because they can see the signals as well as hear them, so they expect to see, what they expect to see. So I think, there is a problem there with trying to get that across. But couldn't the manufacturers, the OEMs, as you call them, do more in the sense of, really, I take your point. The design is made so that it copes with 10 meters and 6 meters in a box that does all these different bands. Surely they could automate the fact that this attenuator comes in for the lower bands and just take the problem away from people. I mean, it just seems ridiculous that we've still got manual attenuators across that's parts of the spectrum, not even individual bands. But if it's below 7 megs or below 10 megs or above 10 megs, you'd think that just because you design a radio that's got to cope with the higher frequencies, that operator then needs to press a button on the lower frequencies to make it work properly. It just seems a bit counterintuitive as well. So that was that, and I think the other thing was on the AGC threshold. I think that's really misunderstood. I didn't get that until I could actually change the things on the radios I had, like on the K4 and on the 101. Then you really get to understand, as you said, by listening to playing around with the settings and seeing what happens. But most people who come into this now are frightened to play with the settings in case they break something. So again, we do need more guidance, I think, from people who can explain it very well, like yourself, about why these things are worth experimenting with, and what typically, like you said, for the rise times on key clicks on those sort of settings, most people would never touch those settings unless they're given advice. Well, this is generally better because it prevents X, Y, and Z. for AGC thresholds, this is what you ought to be listening for when you're tuning between signals in terms of noise levels and volume control and stuff. So that's how you choose a particular AGC threshold, because just saying you've got to adjust a AGC threshold doesn't help a lot of the people that we're trying to help, I guess.
Right. Well, I'm going to give you some examples where you say, well, why in the world doesn't the OEM make it impossible to use your preamp on 80 meters? Well, there was a flex radio that I was using at my quiet QTH on 75 meters, and I was comparing it to an ICOM 781, which at that point was 20 plus years old.
Right.
It was daytime. It was like 8 o'clock in the morning. And so we were beginning to lose the skip. And I could copy the signal at least Q4 on the ICOM, and it was Q0 on the flex because it didn't have enough preamp gain on 80 meters.
Right.
Now that was shocking, but true. So you really can't do what you suggested because they have a corner case.
Yeah.
Well, I installed a beverage a year and a half ago, and I haven't been all that happy with it, but I need to add about 20 dB gain to once the beverage has 800 feet of coax come into the shack. It's meant for 160 for the most part. You need that you need that gain. Now, I could get that gain in the receiver without the external, but then if I was switching back and forth between my transmit antenna and the receive antenna, then it was terrible because there was 20 plus dB difference in the levels. So it unfortunately, intuitively, it makes sense, but in the corner cases, no.
Yeah, I guess it's a default thing rather than a prevention thing. But yeah, okay, great. I'll take that point.
Eric?
Thank you.
Yeah, I just wondered in terms of the tube amplifiers and the transistor amplifiers, I think you said the tube ones are cleaner. What is it in the amplifiers that creates bad signals? I guess now I'm worried that my KPA 1500 is spreading distortion all over the band.
It is.
Well, amps do.
Yes.
So it. I'll talk to a person on 75 NVIS that I probably can talk to once a week. He's under 100 miles away, and he's 30 over 9, and his signal is about 12 kilohertz wide that I can see on the band scope. Now, admittedly, normally we don't have that much signal to noise ratio because at my place at 8 o'clock, the band noise on the S meter, which of course is not accurate because it's a 3 dB per S unit S meter, not a 6. But other than that nonsense, we've got like a 50 or 50 dB signal noise ratio, and I can see that. The bipolars are a little bit better than LD-MOS, but about everything's LD-MOS now. They're just not that linear, and they go into compression. If you say you got a 1500 watt amp to your KPA 1500, but it really starts to compress at a kilowatt, and then at the low end, it probably is nonlinear as far as the curve the other way. It's just the LD-MOS is relatively inexpensive and relatively doesn't blow up much, but it's not very linear. And so you're lucky to be down 30 dB on DBC. Now, the only way properly, as far as I'm concerned, to measure intermod is you put a cursor in your spectrum analyzer. You put a cursor on one of the two tones that are equal in strength, and then you put a cursor on whichever intermod product you want to measure, third order, fifth order, etc. And that's your real intermod numbers. But of course, all the OEMs and the advertisers decided we're going to add 60 dB to that PEP. Doesn't make it any worse or any better. It's a bigger number, but it just splatters just as much, which annoys me, but that's a techie nerd problem. So, but we could say, well, now we're just not, tube amplifiers are probably going to fade away because the tubes are so expensive. I mean, I'm never going to buy a solid state amp, but I've got ACOM and Alpha, and they work. And they're very clean in comparison to the LD-MOS. But once the pre-distortion is in the correction loop, then his third order will be down in third and fifth because it pretty much brings everything down to kind of a plateau. At least we're going to be down 50. That IC 7760 barefoots minus 60 approximately. The 7610 with the DPD is down 50 approximately. And the PW2, 45 or whatever it is. So that's just sort of the way. That's with pre-distortion. Without it, you're probably lucky to be down 30. So the commercial world, like digital TV, pre-distortion or it wouldn't work. Your cell phone transmitters, pre-distortion or it wouldn't work. So we're kind of late to the program, and we only got 3 of the 6 OEMs doing it.
Mm-hmm.
Well,
Anybody else? Go ahead.
Yeah, we've gone an hour and 15. So you won't hurt my feelings if you want to say 73, and glad to be invited to chat with you today.
Thank you very much, Bob.
Thank you
If
very
anybody
much.
else has any questions, I think that's it. I can't thank you enough for your presentation. It was excellent.
Thank you very much. Enjoy the weekend.
Thank you, Bob.
73.
Thank
Bye,
you.
Rob.
73.
Cheers.
Bye-bye.
Okay.